Ladies and gentlemen, it's my great pleasure to be able to welcome you to the 2014 Echoes of the International Fame Lab. And to Prague have arrived an amazing group of young scientists with incredibly entertaining stories to tell. And these are all contestants from the International Fame Lab competition that was held this year in Cheltenham in England. And my name is Michael Lonsborough, and I'll be hosting today's event along with the most charming Katja Sefton.
Today we'll have the pleasure of witnessing a truly international scientific extravaganza. Just a quick show of hands. Who knows what Fame Lab is?
Right, so that's rather disappointing. It's all over here. There's a concentration of Fame Lab people over here. So the rest of you aren't familiar with Fame Lab, so please allow me to just explain the brief outline of how it works. Fame Lab is a competition for young scientists, during which they can talk about their work or, in fact, any other aspect of science that they would like to. And they've only got 3 minutes to do it. And they're not allowed to use any projections or PowerPoint displays, but they can use any props that they bring with them onto the stage. Okay? So, of course, after they all have their 3 minutes, there's usually a panel of judges, and they make a judgment on the performance of the individual speakers, a bit like, Československého superstar.
No singing though. Things are going to be a bit different also today because there won't be any competing. So after the 3 minutes of presenting, you guys will have the opportunity to ask any question that you might want to know.
That's right. I think that's the biggest difference today. It's all about fun.
And science.
And science. Well, science and fun for me are equivalent words. And it's no pressure, okay? We're going to enjoy ourselves. There's not even going to be a strict pressure of 3 minutes. What's really great is that afterwards you'll be inspired to ask some questions. So I think that's what's important today. We want to see some sort of interaction between the people who are presenting and you and the audience.
But before we get to the presentations, we should thank the people that have made this today possible. Namely the British Council, Nadační fond Neuron, Akademie věd České republiky, Czech Centres, NGO Editor, and Cheltenham Festivals, and last but not least, the Tomáš Baka Foundation.
So yeah, a round of applause please. Without their generous support and help, these amazing events wouldn't be possible, so thank you very much indeed. And also we have the pleasure, the luxury to have with us the director of the British Council in the Czech Republic.
So please welcome to the stage Mr. Justin Spence.
Can I just say, to start us off, welcome. This is just such a wonderful room, isn't it? Gaze above you for a moment, it's just stunning. It's great to be here. On behalf of British Council, the Cheltenham Festival, but also as part of the Academy Science Week, I think this is a great event. I'm really passionate about communication in science, and you may ask why. Well, I have a little confession to make, and I'm sitting here in front of lots of people who are very qualified scientists. I'm a failed scientist. I wanted to become a marine biologist, but I was a lazy teenager. Not only a lazy teenager, I was partly failed by my teachers, I have to say. This was a long time ago. But my teachers in physics and chemistry just failed to ignite that flame of enthusiasm that could have taken me to a very different career, and I wouldn't have been standing here today. So I feel, and it's partly this kind of nagging feeling that I could have done something different, that communication in science, the persuasion, the inspiration, the energization of science for young people, young scientists, to become brilliant older scientists is so really, really important. And I think the FAME Lab and the Academy of Science Week is doing a fantastic job in promoting that. So as part of the British Council, I'm really, really pleased that we are doing that. There's also a more serious side to this science communication business. Here we are, hurtling in the early part of the 21st century into quite serious problems in terms of climate change. And there are times when it feels that the argument from the science communication side is not always being won. There are very powerful forces which seem to be slowing us down there. So science communication is really, really important at this time in our lives and at this time of this second of our development as a human species, I think. So with that rather poignant thought in mind, I'd like you to enjoy. You've got 8 fantastic, creative, buzzy, sensational presentations to look forward to here. And I'm sure that you'll be inspired to ask lots of questions. I hope you enjoy it and have a good session, everybody. Good luck.
Well, we should crack on, shouldn't we?
I think we should. So, ladies and gentlemen, our first visitor from abroad has come all the way from... What are you doing? What are you doing? Hey, you've got to be careful there.
There's a fly here.
Wait, Captain, stop. No, really, stop.
There's a fly.
Stop. You've got to be careful, otherwise you're going to start a tornado in Japan.
What?
Japan, a tornado. You've got to be careful with that flapping around.
Japan?
こんにちはさん。マイクさんや。はい。それがズズズズおい。おお、出てた。はい。うわ、すごいな。じゃあ、せやな。Tornado now, Sendai has just hit there, and it's all your fault.
How can it be my fault?
It's all your fault. I know
I've
it's your
never been
fault.
to Japan. I've never been to Japan.
Your fault. And to explain to you, or please give ladies and gentlemen, a big round of applause. All the way from Italy, we have Marco Ferrigo.
Well, you might have heard that the flap of a butterfly's wings in Brazil can set off a tornado in Texas. But what is the mathematics behind this catchy phrase? To find out, I will describe to you an experiment that involves the typical mathematical tool, soap bubbles. Okay. The first part of the experiment is very simple. Just take your bubbles and blow them. The first part of the experiment is watch closely at the outcome. Watch how many bubbles form, how long they live, and which direction they take. The second part of the experiment is a challenge. Try to reproduce exactly the same outcome. So what can you do in order to do that? You can try to reproduce exactly the same initial conditions. So you will try to stand at exactly the same spot. Put your stick at exactly the same height and blow with the same intensity. And well, even when you try yourself, you will find that any shot you try is completely different from the others. What happens is that the first and the second shot, in my case, follow a similar path for a couple of seconds, or even less, as in this case. But then some small, tiny differences in the initial conditions, such as a different inclination of the stick, or a slight difference in the intensity of your blow, may have the time to evolve and weaken. And what happens is that the two shots result in totally different outcomes. What this experiment shows is how weather prediction works in some way. The meteorologist's work is collect data about air pressure, wind intensity, air humidity, put them in computers where sophisticated mathematical models have the possibility to create that multimedial accelerated version of reality that you see when you watch weather forecast programs on TV or on the internet. But what happens here again is that reality and its simulation can follow similar path for a certain amount of time, but then some small, tiny differences, such as an unmeasured flap of a butterfly's wings, have time to evolve and unweaken and end up in totally different outcomes, such as an unpredicted tornado. And this is how the flap of a butterfly's wings, if not properly measured, can end up in an unpredicted tornado. With modern technology and mathematical models, the edge of predictable is 48 hours. But how far can this edge be pushed? Well, this is a challenge that each and every one of you is well invited to take, because we still do not know. Thank you. But let me try a nice shot of bubbles, please. Ah, this one was nice.
Well, thank you, Marco. So it is her fault, the tornado in Japan.
Yeah, definitely her fault.
It's always my fault, isn't it?
Does anybody have a question for Marco? There's some interesting, yes,
The lady
the young lady in the front.
I would like to know, I just learned that I can trust the weather forecast only for 2 days. But on the other hand, there is a story about the global warming. How can I...
Wow, even more difficult. Global warming. Well, if from a mathematical point of view, what you can try to do is actually try to understand. What I was trying to explain is that in mathematics you can try to understand how things interact with each other, not just in mathematics but in science in general. And in order to make predictions, you have to do 2 things. Very well how things interact, for example wind, or for example how the temperature interacts for, I don't know, the ice in the poles, and how this interacts with the sea level and so on. But the other thing is to collect data, because you cannot reproduce what will happen if you do not understand what is happening in this exact moment, at the starting moment of your model. So I think that in the global warming it's an extremely complicated model, also because you are trying to model something that is happening all around the Earth. While in weather prediction in Prague, for example, you can just focus on the weather condition in the Czech Republic, which is not as big as the world. For global warming, it's a global problem. So from a mathematical point of view, which is quite simplistic, I mean, it's a really huge problem. But from a mathematical point of view, the main difficulty, I think, is collecting data in such a huge environment.
So you've got a difference between weather and climate. So I suppose it's a bit like, I'm a chemist, so if I think about, I don't know, a reaction which I know will always finish in the same way, if I were to follow just one molecule, the weather, then that molecule can do anything. Quantum mechanics says it can do all sorts of different things. It won't react, some will back this way, that way. But together the whole system is predictable. So I think is that fair to say that it would be like a different metaphor for the climate check? So climate is a more predictable system over long because it's about a trend, whereas the weather is like following a single quantum event, whereas it's far more unpredictable.
Yes, I understand. Yes, it might work.
Has that started any of your sort of juices flowing? Do you have any questions? I might have one question. If these things if a small event can lead to a very sort of warped big thing, does that mean that individual choices can have all sorts of different outcomes? And whether all the outcomes are possible in multiple universes?
Wow. So quantum physics you're asking about. Well, this is very interesting. It makes me think that mathematics deals with simple problems. This might sound strange, especially to you who are still in high school. You might see, I don't know, but you might see mathematics as dealing with some, I don't know, theoretical stuff, not interesting. But what it really deals with is the simplest idea you might have. So when it comes to people actions, which is really difficult, a a scientist in general would say, come on, let's start seeing a man as a cylinder, okay? Which simplifies from a scientific point of view. When it comes to people actions, well, that is an extremely difficult model to make predictions on. You can't just quantify actions with equations. That is even more difficult. So definitely, yes, every small actions that we perform, for example, for you, coming here and seeing great scientists who will talk, maybe will have great influences in your life, and one day you will become scientist just because you came here. Or another sliding door, you just come here and fall asleep and say, no, I don't want to do science, but that's not what is going to happen. So, yes, definitely.
Any questions? Well, if not, thank you, Michael. Michael, what are you doing?
I am a robot. I am a robot.
Robot? No, you're not.
I am a chemical robot. Chemical robot, chemical robot, chemical robot.
He has no idea what he's talking about. But to tell you about real chemical robots, please welcome Jitka Čejková. Hello. Do you know any English word that comes from Czech language? Yeah, exactly. Robot. This word was first introduced in 1921 in the Karel Čapek's famous play RUR, Rozum's Universal Robot. The term derives from the Czech word robota, which means forced labor. And what is the play about? A mad scientist, Rozum, discovers how to create artificial life and starts creating artificial human beings. What follows is a factory for making robots, a robot rebellion, and the extinction of human race. The robots in the play are not human-like beings, but in the play the robots are not clinking metal constructions, but human-like. They are made of protoplasm, a substance which behaves exactly as living matter. Čapek describes that as a blob of some kind of colloidal jelly that even a dog wouldn't eat. I work in chemical robotics laboratory. Our chemical robots have some properties as Čapek's robots. So they have no wheels, no electric power, and no computer systems to control them. They are based only on chemical principles, and they are also made of colloidal substances. But our goal is not as big as Čapek's. We don't want to create artificial human beings. We are much more modest. We are content with creating small artificial cells or small artificial organisms. Our chemical robots have properties, what properties as we can see in nature. So living cells are able to respond to changes of pH or temperature, as do our chemical robots. Living cells are able to absorb molecules and process them with chemical reactions, as do our chemical robots. And just recently, we taught our chemical robots another thing, to move chemotactically. And what does it mean? Living cells are able to follow gradients of an attractive compound or to run away from the source of harmful substance. So our chemical robots are able to follow additions of salt in complex mazes. At the moment, our chemical robots, in the form of oil droplets, are training to become transporters of chemicals, a sort of chemotaxi. We hope that in the future they could serve as transporters, for example, for targeted drug delivery. So we have a nickname for our chemical robots, Cobot. And if our project will be successful, maybe the word cobot will enter into the English language as Čapek's robot. Thank you. Any questions? Yes?
I have a question. You mentioned that Čapek in his book said that the
also alginate for preparation of our particles, and it's possible to eat them. So, but I never tried it, but it's possible to eat some of them. Yes?
How do you teach them to do what you want?
They are based only on chemical principles, so they feel gradients of some chemical compounds and they are able to follow them. So our recent research is focused on oil droplets, decarboyl droplets, and they move in 2D mazes and they follow salt additions. Maybe you can find on YouTube our movie. It has almost 300,000 of views in YouTube, and there you can see our funny labyrinth with oil droplets, and our chemical robots follow salt additions.
So you basically have a 2D maze, and just by altering something in their environment, like putting in a salt molecule, they sense that and they go after it.
Yeah. They feel salt, there is the salt gradient, and because of gradient of surface tension, there are some molecular flows, and that's the reason why our oil droplet move. But the idea is that we will not use any electric devices to control them. They will feel chemical signals, and they will respond to chemical signals.
Maybe we can have a show of hands. Who would be willing to have a chemical robot put inside them? So only 3 of us. So
There's a fourth one in the back.
So the rest of you would feel a bit apprehensive about having a chemical robot inside you. Is that right?
But we hope that in the future they will be able, for example...
But your project needs a better PR. You need a better PR man to work on the chemi robots.
Are you applying for the job?
No, I'll gladly have a chemical robot implanted in me.
So maybe
Test subject number 1. There you go.
So, any other questions? Has anybody wondered about... Yes, please.
The young man in front.
The young man in front.
Where will chemical robotry take us 20, 30, 40 years? What's the vision?
What is the vision when we will use it? I think it's far future challenge, because we can find something, but there are many steps to use it in the real life. So there are many tests and studies.
But what's the vision? I mean, do you envisage that in 20 years we'll be going to the doctor, and the doctor will have on the shelves all these different little chemical robots, and they just take a few and then the chemical goes...
Yeah, the visions are like this, that we can have robots in our body, and they can also send some signals also to us that something happened wrong. It could serve also as the device for diagnosis of the...
For example, chemical robots that are continually cleaning my arteries from cholesterol.
Yeah. Also, it's one of the ideas. Yeah.
Yes, fantastic.
Now you can eat all those sausages.
Yeah,
Not worried.
sausages. I mean, maybe many of you are too young to... Do you know the film Inner Space? Did you ever see that? Am I the only person to see Inner Space? That was a great movie. So when I was a little kid, it was about... Actually, Tomasz, you're as young as I. Inner Space is about... Have you seen Inner Space? It's about how they can miniaturize somebody to become the size of a cell, and they put him into the person, and then he could go around and float around in different parts of the body and do all these mechanical operations.
In Czech, it's another thing.
Vnitřní vesmír. Asi.
Yeah, it's another thing. But I know what you mean, but I don't know what in Czech.
There's 2 people in the room who know what they mean.
Yeah.
Any other questions?
If not, then another
Thank
round
you very
of
much.
applause to yourself. Katja, what is that ridiculous thing you're wearing on your head?
Green revolution, baby!
Yeah, go. Revolution, what revolution?
Look, Michael, I've been doing my research. I've been reading up on it, and it's coming. You just can't stop it.
I mean, you're not making any sense to me.
And that's why I've invited over my good friend, International FameLab 2014 champion, Porrick Flood.
Imagine you're inside a leaf. It's a sunny day, and the cells around you are glowing with the soft green light. You move into one of these cells, and you see that this green glow is coming from melon-shaped objects called chloroplasts. As you look closer, you see tiny antennae harvesting this light and channeling it down to a reaction center. It is at this point that light becomes life. This process is known as photosynthesis, literally building with light. It is the fundament of all life on Earth. The energy I'm using to talk to you right now, the air we are breathing, and even the fossil fuels that power our economy, all come from photosynthesis. I'm telling you this because our population looks set to reach 9 to 10 billion by 2050. This is a massive increase in the number of people that need to be fed, and it is way beyond our current capacity to produce food. But believe it or not, we have faced such a challenge before. In the 1950s, the world's population reached 2.5 billion, and for many experts, further sustainable growth seemed an impossibility. They predicted massive famines and the collapse of our civilization, and referred to it as the population bomb. But thankfully, some scientists did not give up. They had a vision, and collectively they brought about an agricultural transformation like nothing we have ever seen before. They quadrupled yields in a matter of years in what became known as the Green Revolution. The man who spearheaded this was Nobel Prize winner Norman Borlaug, who is credited with saving more lives than any other individual in the history of our species. His work was so incredibly successful that in the developed world we went from potential food shortage to food mountains, but this is no longer the case. The population time bomb has not stopped ticking, and that is where photosynthesis comes in. The scientists of the Green Revolution did an amazing job at increasing crop productivity, but they never managed to improve photosynthesis. In fact, some scientists still say that it can't be done. But already, from my own research, I say otherwise. There is a resource out there, a resource which is a fuel of evolution and which we can tap into. This resource is genetic variation. In the case of photosynthesis, this variation manifests as differences in the efficiency in which plants convert light to life. The genetic basis of these differences can be used to create plants which will feed and fuel our future. We must increase the productivity of our crops so that we can buy the world time to reach a point of population stability. In the words of Norman Borlaug, you can't build a peaceful world on empty stomachs and human misery. We need a second green revolution. And photosynthesis is one key which cannot be left unturned. Thank you.
Okay, before I let you guys ask, I have to know what's going on with that bid. Are you auditioning to be a villain in the next
This is for charity. This is not for style. Very clearly. You've heard of Movember? Yeah, so this is my attempt.
Yeah, I've recently finished a short book written by an eminent British scientist. I think he's an expert in computational programs. I think Chris Emmett, or his name. He wrote a book called 10 Billion.
Okay.
And about the projection of a bit what you're saying, projecting into the future, that soon we're going to be 10 billion people, and how can we actually do something so we can feed 10 billion people. And it was quite a scary book. But do any of you have an opinion, or do you have a question about how we can use photosynthesis or to feed an ever-growing population? Maybe I've got a question. Go ahead.
Which part of the photosynthesis process is the most promising part which you would like to improve?
Okay, he's asking about the most important aspect of photosynthesis to improve. Because photosynthesis is it's kind of a series. There's multiple systems along the way, and they pass electrons, and some of them pump protons, and other ones do biochemistry. And currently, probably the most limiting part is the biochemistry, because that occurs much slower than the biophysics. Because the biophysics is dealing with electrons, is dealing with light, that's really, really fast. And that's usually operating at a much higher rate, or can operate at a much higher rate than the biochemistry. So most people focus their energy on improving the biochemistry. But even so, you must consider the plant is a complete integrated organism. So if you improve the biochemistry, but you don't also improve the architecture of the leaves, the position of their leaves, the roots, then you will not get a sort of a good result. So you really have to kind of improve everything in tandem, which is why it's such a difficult thing to do. And you have to tweak lots of different things to get a desirable outcome, basically. So there's no one answer to that.
Any other questions?
There's a question in the back.
So you talked about improving photosynthesis to solve our food problem. Is there any possibility in improving photosynthesis to solve our energy problem?
Yes, it's a very good point. So there are a lot of people doing that. And one of the problems with, so people want to use plants as a source of biofuel or algae, is that if you use biofuel, it often directly competes with food. And for people that are poor, maybe somebody who's wealthier has got more money to buy fuel, and then somebody's left without food. So this is a bit of an ethical dilemma. And one way of getting around this is to use organisms which we do not normally use for food, and which occur in regions of the earth which we also do not normally use to produce food, so that there's no competition between the two. And what a lot of people are trying to do is that they're trying to create algae which will live in the seas or in salt ponds, which are areas that we're not actively using as food resource, and increase their photosynthetic productivity under these conditions to get more biofuel out of them. Some of these algae will even directly make oil. In fact, oil is just fossilized algae. It's fossilized photosynthesis. So every time you burn oil or coal or whatever, the light that comes out is the light of a sun that shone 300 million years ago on those plants, and it was just trapped in that coal. So you're releasing ancient sunlight. It's a nice thought.
Any other questions from this half of the audience, perhaps?
Yeah, come on. I mean, please ask a question.
He
Don't
likes
be
to
scared.
talk.
Don't be scared.
I mean, well, let's do maybe a show of hands. Ask a question you can participate in. I mean, would you rather live somewhere that you were, as a major source of energy, you were burning fossilized fuels, or where you could actually use this year's photosynthesis as the main source of energy? Is that an attractive, appealing thing for you?
Show of hands for photosynthesis.
Again, yeah. So there's quite a few fossil fuels there. Right. Well, let's move on rather quickly. But presumably, the main sort of method that you'll be using to increase the efficiency of photosynthesis will be genetic modification. And if you do that, won't you lose genetic variants?
So that's a very good question. But I would like to point out that we're not. So, does everybody here know what is meant by a GMO, by a genetically modified organism?
Show of hands.
I need to.
Who knows?
Who knows what it is? I won't make you tell me, so don't worry. So not very many. So what most people understand a genetically modified organism to be, and what is generally talked about in the media, is an organism where you take a gene from another organism and stick it in it. So you copy and paste. And people get really scared about this because they think we're playing God. What I'm talking about is natural genetic variation, where you look within a species, so in this case a species of plant, let's say rice, and you look at how it varies. And then you say, okay, so this guy has really high photosynthesis, and this one has low. What's different in their DNA? And then to try and relate that difference to the capacity to perform photosynthesis. And then you take all of the high guys and you use them to create a population of plants with even higher photosynthesis. So you combine the best bits from different ones just through crossing. And that's considered traditional breeding. So it is modification of genetics, but it's not modification of genetics using biotechnology. So everybody thinks that's fine. Ultimately, it's the same thing, but we have this kind of funny feeling when we do copy and pasting. It's the same thing. But yes, reducing genetic diversity, if you have a very high selection coefficient, yes, but I think we can avoid that with very large populations, and then that should be fine.
Any questions? No?
One here.
You explained very well how science
But what could we, especially young people, every one of us, what could we as individuals do to be part of the green revolution in your opinion?
Interesting question. Well, I think you're all students. One of the main things you can do is actually study it and hopefully become researchers in the future in this area, because we need more researchers, basically. I think one of the main things we can do is change our attitudes. So currently, particularly in Europe, we've got a really bad attitude. We're afraid of GMOs. We don't understand them. And we're very resistant to new technologies being brought online. And in some cases that is good. I mean, you have to be sure that something's safe before you use it. But we've gone too far. So I think the best thing we could do towards facilitating a green revolution in the future is to open our minds to new ideas and new ways of doing things, and be willing to adjust and adapt. I think if we do that, we will help further generations even more than anything else I can imagine right now.
Yes?
How do you measure the effectivity of the photosynthesis, especially?
How do you measure photosynthesis?
Yeah, what is the effectivity of it?
Yeah, well, the efficiency.
Efficiency.
Yeah, so there are many ways to measure photosynthesis, because it's not when you look at a plant you cannot tell how good it is or how bad it is. One of the main ways is to literally put a chamber on a leaf and pump gas in with a certain mixture, and then the gas that comes out you analyze, and the difference in that gaseous mixture is because of what the plant is doing to the air. And when the plant is doing photosynthesis, it is sucking up carbon dioxide and spitting out oxygen. So these differences you can then say, well, it's taking with this amount of light and this amount of CO2, it's giving us this amount of oxygen back, so we can say, okay, its efficiency is X, Y, and Z, and then you can change the light, and then you can estimate its efficiency, and then you can compare different plants and see which ones can do better under the same conditions. There are also other ways of measuring it using light pulses, which are a little bit easier, but that's probably the main way to measure it.
What's the spread in terms of percentage efficiency?
Across species,
Yeah.
it's huge. So there are like that plant at the back there, just in front of the mirror. That's got a very low rate of photosynthesis, but it can survive very well under low light conditions, which is why we grow it inside our house. But if you give it a lot of light, it can't do anything with it. It's not able to manage it. So its maximum efficiency is very low, but its efficiency at low light levels is very high. So it's a bit of a trade-off. If you go to a crop, maize, for example, cannot grow in the shade. It would die here, but it can use a lot of light very efficiently, so its maximum capacity is much, much higher. And the spread between them is huge. I mean, this could be, let's say, a number of around 5, 6, 7 micromoles per meter squared per second is the units we use of CO2 fixation, whereby maize can be 40 or 50 in some cases under optimal conditions.
Can you put like a percentage in terms of the energy that's falling on a maize crop?
Oh!
And the energy we can get from, say...
Yeah. So maize, under optimal conditions, theoretical maximum of total sunlight coming in at the edge of the atmosphere, keeping in mind that some of it's reflected and some of it's outside the spectrum that the plants can use, can probably only take about 4.6% efficiency, which sounds really low, but it's actually pretty good compared to most photovoltaics. Some photovoltaics are higher, but they don't produce biomass and they don't produce oxygen and they don't usually make chemistry. So.
Right. Is anybody here scared of a green revolution? Anybody here got an opinion that, you know, that's a negative thing? Is anybody scared here of Monsanto?
Yes, well, I am too.
Well, maybe that's the question. Do you have what's your opinion? Are you worried about that maybe companies like Monsanto can take over these green revolutions, and you know, they become the determining factor in what we will be eating and how we're going to be feeding populations?
Yeah, I am, and I think actually one of the main reasons that they can do that is because we are afraid. Because we are so afraid, we have made so many laws supposed to be protecting people and limiting innovation in this area. The only people that can afford to do it are big companies because they can pay the legal fees. So small companies with diverse approaches, they don't have a hope in hell of doing something like that because they'll never manage to get through all the paperwork and everything. Forget about the actual research. So I think actually our current attitude is actually helping companies like Monsanto. Although for them it's also a pain in the ass because they've got to fill out all these forms. And they spend as much money on their legal department as they do on their research department just to get through all this bureaucracy and everything. And it is a worry, But also bear in mind that it already happened. People forget this. So when you do breeding, currently most crops are sold as F1 hybrids, which means that they are the offspring, the children of two inbred lines. And these inbred lines are kept very protected and nobody gets access to them. And you can only buy the seeds of the F1 hybrids. If you're a farmer, if you keep those seeds, the children of these F1 hybrids are going to be completely different. So you cannot grow those seeds again. You need to buy them every year. And this is traditional breeding. So already they've got that in the bag. So this fear of GMOs, it's kind of unfounded in some ways. It is legitimate, and it is something we should think about, but I think we've gone too far. And I think we're actually helping those big companies more.
And on that note, thank you very much.
So,
I need a coffee. Coffee, 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 coffee. Give me a coffee.
Michael, what are you doing?
I need a coffee.
You already had
No, I need a coffee. I haven't slept for 4 days. 4 days, I need a coffee.
Why?
Well, I'm trying to reduce the amount of melatonin.
You've been reading the papers again, haven't you? Ladies and gentlemen, please welcome Jana Bagiewska from Poland, who'll explain what Michael's going on about.
I need a coffee.
Who here feels like they could use more sleep? But would you be so keen on taking a nap, gentlemen in the audience, if I told you that sleep could shrink your testicles? Before you panic, bear with me for 3 minutes. Let's start with sleep itself. We are wired to sleep at night, but how do our bodies know when night is? In our eyes, there are photoreceptors, cells which differentiate light from dark. Fair enough. But how would our liver or kidneys know the difference between day and night? Well, when it's dark, photoreceptors send a signal to the brain, to the pineal gland, which starts the production of melatonin. Melatonin is the hormone of the night. It's a chemical expression of darkness. It flows through our blood and lets all our organs know that it's dark and it's time to go to bed. Because of that, in some countries, melatonin is sold as a supplement for people suffering from insomnia. However, some time ago, a study was conducted in which melatonin was fed to hamsters. Worryingly enough, as a result of melatonin intake, the hamsters' testicles shrunk. The news hit the media and panic ensued. You can imagine the headlines of the tabloids. Men, if you take melatonin sleeping pills, your balls will be the size of peanuts. But will they really? Let's go back to the study. If we feed hamsters more and more melatonin, it's a sign for their bodies that periods of darkness, i.e. nights, are getting longer and longer. And what does it mean when nights are getting longer and longer? Well, winter is coming. And in winter, hamsters, like many other mammals, would undergo what is called daily torpor. Their metabolism slows down. Because it's cold outside and food is scarce, they try to shut down all the non-essential parts of their bodies, such as testicles. After all, in winter, a hamster is focused on survival and not impressing the ladies. So, yes, in hamsters, melatonin does cause testicles to shrink. But does it hold true for humans too? Well, no. We don't hibernate in winter, so men's testes are the same size throughout the year. So I have 2 take-home messages for you. First, be very cautious when interpreting the results of animal research, because they are not always directly applicable to humans. And secondly, gentlemen, you can sleep soundly. Your gonads shall remain safe.
Well, that's come at quite a relief. So, any questions about testicle sizes, hamsters, melatonin levels, sleeping? No questions about sleeping. Do you think you sleep enough? No. Does anybody think they sleep too much? No. Well, I tell you what, I've got a question for you then.
Okay.
What's the ideal sleeping pattern for a young human being?
Like me.
Like Katja?
Oh gosh, I would say as much as you feel like you need, but yeah, maybe a few words of warning. I'm a zoologist, so don't ask me about humans. You're beyond my scope.
Okay,
ask me about
other primates.
other primates. Well, other primates don't have work to go to, so that's quite convenient. But for instance, if you look at orangutans, they tend to wake up at about 4 a.m. maybe, and then they go to sleep at about 10 p.m. So they are on kind of a similar schedule to us. But if you look at carnivores, for instance, so all your lions, your large cats, your large canids, wolves, etc., even things like mink, they sleep for most of the day. So they conserve energy by sleeping. And then when they wake up, they go hunting, they go to eat, and then once they've caught something, they go back to sleep. So if you have a cat or a dog, you probably have noticed that for the entire day, all they do is kind of sleep. And this is what happens in nature as well. So there are different sleeping patterns in different animals. Giraffes, for instance, would sleep very little, even as little as 15 minutes per day. So this sounds ridiculous because you've got this huge animal, but it doesn't need that much sleep. Dolphins would switch off half their brain, and that's how they sleep, that's how they rest their brain, which is fascinating as well.
I generally
Any questions?
half a brain.
Oh, no.
Yeah.
You said that you talked about animal tests and how to interpret them, and you said that we should be really careful about that. But do you think that we should always test, for example, I'm thinking about products, chemical products, beauty products. Do you think that we should always test those products on humans before selling them, or is there a way to avoid human testing? What do you think?
Well, I don't think I would want to use a product that has never been tested. And for safety reasons, they should be tested. How they are tested is a different story. So a lot of the components that go into beauty products, for instance, have already been tested. So you don't need to retest them again on animals. So for welfare reasons, you really don't want to abuse the fact that you've got a guinea pig or a rabbit and you want to put more beauty products in it and see what happens if you already know what the results would be. Because scientists are not sadists. We don't like experimenting on animals unless we have to. And so a lot of the products, I think in the EU, cosmetics have already been tested ages ago. And so right now any new products are not being tested on animals. At the same time, before you release something new, you want to see what happens. Interestingly enough, when you test medical products, there is a bias because a lot of the animals that are used in the labs, a lot of the mice, let's say, or rats, they're male because it's easier to work with male mice because they don't have their estrous cycle, so the hormone levels are pretty much stable throughout the week or the month. And so you've got this kind of male bias throughout the laboratory testing process. And then when it comes to humans, on a much more complex level, there are very big differences between the bodies of males and females. And so because earlier on you have not done enough testing on one of the sexes, you sometimes may get into trouble because of that. So this is again something to bear in mind.
Just had a really good idea actually listening to it about the hibernation thing you're talking about,
Yeah.
which could link into the Green Revolution. Rather than having the Green Revolution or in sort of parallel to the Green Revolution, we can sort out our overconsumption by genetic modification of human beings to hibernate, and therefore they have at least, say, 4 or 5 months where they don't consume anything.
But then your testicles would shrink. Are you willing to do that?
Okay, you'd have smaller balls, but it means that more people could live on the planet. Do we
Do we want more people living on the planet though?
Well, I mean,
Maybe with
do you
the
want to
smaller
stop
testicles, there wouldn't be so many.
do you want to stop people making children? I don't know. It's an important question. But do we understand how hibernation genetically evolved?
Well, it depends on the organisms, because you have some sort of hibernation in all sorts of organisms. So you get the like Daphnia. So these are tiny little microorganisms that can survive in their little capsule hibernate form for years until the conditions are right for them to hatch. And that, of course, is very different to a hamster just falling into a torpor stage in winter where the temperature is lower, but ostentatiously, when you just increase the temperature, the conditions are right, there's more light around the animal, it will wake up without a problem. So you have to look at each taxonomic group differently. You have toads, for instance, in Australia, that they don't technically hibernate because they don't avoid the cold, they avoid the extreme heat. So they would dig holes deep into the ground, stay there, wait for the rain to come and for the temperature to cool down a bit, and then they'll emerge. So it's very different in all sorts of taxa.
Anyone have any questions? No? Okay, thank you, Anna.
So, Katja, you started university in England, so how's it going?
Pretty damn good.
You having a good time?
Oh, yeah.
Yeah?
Sometimes even I make it to lectures, once or twice a week.
That's good, it's good.
3 times on a good week.
And anything else? Anything you want to...
Well, there is something.
Go on.
No, you have to promise not to tell anyone.
Oh, it's a secret?
Anyone, it's a secret.
Well, I can keep secrets, and I can keep
No,
secrets.
Michael, I'm not kidding. No one can
No,
know about
I
this.
am good at keeping secrets, don't worry. I promise I'm poor on chemistry, I will not tell anybody.
Pinky swear?
Pinky swear, I'm not telling you. Oh my god, she's pregnant!
Michael! You said you
You're
wouldn't tell.
pregnant! I got it! Promise me one thing, Katja. One thing.
What?
When the baby comes, you've got to phone up Matthias and for him to do that mass spec thing.
Who do what?
Phone Matthias to do the mass spec thing on your baby. Listen, okay. The next speaker's going to tell you all about it, the importance of doing the mass spec thing on your newborn child. Ladies and gentlemen, please give a big welcome to Matej Krit, who's the winner of the Czech competition this year. So, a big round of applause.
Dear friends of science, you are probably wondering if it's a boy or a girl. But what you should be wondering about is if it's a healthy boy or a healthy girl. Our patients are newborns suffering from disorders in purine synthesis. Purines are organic compounds that serve as the basic building blocks of our DNA. These disorders have neurological effects, including seizures, autism manifestations, and delayed development. Those symptoms are common for many diseases, and therefore the correct diagnosis is very important in order to prevent wrong treatment. Our aim is to find these disorders even before they are manifesting themselves. Ideally, we would use some method right after birth which would show us that there is something wrong with the baby. By testing a suitable biological material like urine. Okay, so here we have a sample from a potential patient. And now we have to collect a set of samples from healthy controls. Yes, young lady in front, please, would you be so kind be into this tube for me? And you, sir, would you please, can I have your sample as well? And I will create one by myself. Oh, that's great, that's great. Thank you very much. Thank you. Thanks a lot. Wow, you really needed to go, didn't you? You are very kind. Now, we will analyze all the samples of the control patient and the sample from a potential patient. For this purpose, we will use mass spectrometer, or as I like to call it, major mass spec. This machine can precisely measure the molecular mass of a wide range of compounds and provide us our very detailed information about them. From that, we can calculate the concentration of compounds of our healthy controls and then compare them with the concentration of compounds of our potential patient. Oh no! Here we can see the high levels of succinylaminoamide carboxylate amide ribose. Hurry up! We have to go to the doctor and tell him that your disorders are based on the purine synthesis. I'm sure he will know what to do thanks to our fabulous work.
Anybody have any questions?
Would you like to hold your baby? Are you okay?
Yeah, it's a kind of space. There we are.
Otázky může být v češtině. A my to překládáme.
How does major mass spec work?
Yeah, you peek inside and then on the next slide you get your results.
That was a scientific answer.
Yes.
How about
Now, in layman's terms.
Okay, no, mass spectrometer is a great machine. You prepare your sample. Basically, for example, when you analyze urine, you put it into the tube, into the small tube, and the mass we use mass spectrometer in the combination with HPLC, which is liquid chromatography. The liquid chromatography makes the job that brings the compounds from the urine little bit diverse already one by one. So and then it comes to the mass spectrometer, and the very important point is that the mass spectrometer has to give each compound a charge. Why it is important? Because when the compound has a charge, there are strong magnets inside the mass spectrometer, and they suck those charged molecules inside, and then we can measure the signal of a mass divided by its charge. So our result is that we have a compound which goes inside the mass spectrometer, and the mass spectrometer also divides the compounds, the delivered compounds, by their mass, because the bigger molecules are flying more slowly than the smaller molecules, and then the result is not the calculation as I showed. This is something I do in the computer, but we get just a straight line in the spectrum. So it more or less gives me a signal like this, just a line, but it goes I get many of those signals, and I get the information about the mass, exact mass, and which is great, because as probably most of you know, each atom from the periodic table, or almost each atom, has isotopes, which makes this atom slightly more heavier than its calculated mass as you have in the periodic table. And mass spectrometer can measure this one more neutron or proton which you have if you have more heavier atom, which is great, because this is the best weight ever. But don't use it in the kitchen. It's very expensive, and it takes time to give you the answer about the mass.
Yes?
I'm just wondering, how sensitive is your technique? Because I'm thinking, like, if you want to diagnose a baby, it would be even better to do it when the mother is still pregnant. Like, if the mother pisses in a jar,
Yes.
can you tell her what's wrong with her baby? Or what?
Yeah, that's the aim. That's our aim where we are heading to. But first of all, we have to develop the methods for the analysis, because it's very difficult to ask women for any biological material if you are not 100% sure that your results will be positive or negative, because you can't ask. You can ask, but let's say who will give a let's maybe answer a question for ladies. Who of you will get a biological sample during your pregnancy? You normally go for some testing anyways, but would you be willing to give a sample? It wouldn't be any extra procedure, but will you give a sample for research purposes? Who thinks that will do that during a pregnancy, that will give a sample?
Ask each other as well.
Thank you. Because you just signed. Actually, what's the point is that you go to the doctor anyway. The doctor makes the procedure and tells you the result immediately, mostly, and you go home. And the extra thing you would do in this case is that you will sign a paper that you don't mind that the material which is going to the trash will go to the lab, and you will never know the result back. You will be, and the sample will get a number, and it will disappear from your life ever after. Yeah, it doesn't hurt. It's just one signature. But if you like to know the result, you can ask the doctor, please, could you give me the feedback?
But isn't the question that once you're aware that this data is being taken, and potentially you could find out something which could be very important or not, already that's going to bear on the mothers and fathers' minds, and that can induce a change in their behaviour. And I think that's the question: to what extent do people really want to know all that science can reveal? I don't know. I think
I have to comment once more. The concentration is nanomolar, which is really the method is really sensitive. So milli, micro, nano.
A billion to the molar.
Yes.
Any questions? Yes?
I would like to ask if you've already tested it on like a girl or a pregnant lady. Do you have any experience with actual sample and actual?
Yes, we just published a paper which shows that we can analyze succinyl-aminoamine carboxyamide ribose from a. It's not a joke; it's a chemical compound from a dry blood spot. Each baby, each one of you, when we were born, we were giving a sample to the doctors from our a blood sample from our accused to a piece of paper, and also 20 years old blood spots are giving us the information about the concentration of the funny compound. By testing, we can extract from this dry blood spot the blood bank and analyze it, and we just recently published that it's working. So we keep going because the real aim of the research is to find the diagnosis. Because if you can imagine that you come to the doctor and say, "Hey doctor, I'm ill, I would like to know what's wrong," and the doctor says, "We made all what we can, but we don't know. I don't know what to do with you." That's really a bad situation, because if you have a cough, you get the pills and you're fine. But if you have some other type of problem and the doctor doesn't know what to do with you, how can he or she treat you? So that's the aim of this type of research, to help doctors with the diagnosis. Yes, please.
You showed us two aspects of the scientist's work, the theoretical part and the engineering part. How much are you or your team involved in the building and taking care of the mass spectrum?
Yeah, actually 99%. The only trouble is with we are now using cells which we are analyzing. Those cells are genetically modified, and we just made them look like they have the disorders in the purine metabolism. So we can see which type of compounds they accumulate, and those we try to measure and develop the method for starting on the cells and then bringing it to the people and to the public. And actually, I have one short comment to the genetically modified organisms. Each one of us are genetically modified organisms, because when the two cells, one from your mother and one from your father, meet and create the oocyte, the two parts of the DNA come together and exchange some parts. So that's also the reason why we don't look exactly the same, each one of us, or brothers and sisters. So we are also modified. So don't be afraid. It's not a bad thing, mostly.
Any questions? Okay, if not, thank you very much.
No question, but I've got a point. Mainly for Dasha, Katya is not pregnant, really. It's just a joke. Katya, I want to show you something.
Michael, we're presenting. See, audience?
But
us
yeah,
on
well,
stage presenting.
you
We don't
can
have
wait.
time for this.
Just pretend they're not there, right? They can wait for a minute, but you've got to come under here with me. Come here.
What?
Look, come here.
No.
Katya, I'm going to show you something scientific. Just pretend they're not there. Come on, Katya.
You say it's scientific.
That's it.
Well, I can't see anything.
You can't see that?
No.
Well, I can see it.
What? How?
Well, because I've got these new super duper photon intensifiers. Look at that.
That's so cool.
Cool. But do you know how they work?
No.
I don't either. But the next lady who's going to come here does. Her name is Anna Stelko. She's from Germany. She won the German equivalent of FameLab. So please, can you come to give a great round of applause for Anna Stelko, who's going to explain how these photon intensifiers work. Thank you.
Please welcome the Queen of the Night, master of seeing in the dark, who can still fly around without photon intensifiers when there's only stars illuminating the sky. I'm sure you guessed it, I'm talking about this wonderful moth, of course. This is the elephant hawk moth, and this is what I'm working on. The elephant hawk moth can see when it's so dark that even we humans have problems. Why is it so hard for us to see when the light is very low? Follow me on a journey into our eyes, where we meet the light detectors or photoreceptors. They detect light particles, the photons, and if they do this well, we can see well. During the day, this is really easy. There are billions and billions of photons. The photoreceptors are literally standing in a massive, massive shower of photons. I just substituted the light particles for water particles, but same principle, you realize it's really, really simple detecting such a strong signal. During the night, however, there are only very few photons. And the poor photoreceptors, they feel a bit like you when you're out on a grey day and you get hit by one raindrop, and then nothing. And then you start wondering, did I really feel this now, or did I imagine it? Is it raining now? So seeing at night is so hard because there are so few photons drizzling in, and the photoreceptor's detection of these photons is unreliable. Now, how does my moth solve this problem? Well, according to the principle of the great scientists, the Beatles. I get by with a little help from my friends. I'm investigating neurons, that is nerve cells, in the brain of this moth that get help from their friends. They're reaching out to neighboring nerve cells and exchanging information about the photons. That works a bit like when you are out on this rain day, when you get hit by the one raindrop, but you have your friends with you. What do you do when you don't know what happened? You ask, hey, did anybody else feel something? And if one or two of your friends also felt a raindrop, you can be sure you didn't imagine it, but it's actually raining. So you can make your detection of the very rare signal more reliable by exchanging information with neighboring detectors. We call this principle spatial summation, and this is what the moth's neurons are doing in her brain to improve vision at night. You might wonder now, who on earth is interested in how moths see the world? Well, for example, companies that develop cameras that help us drive our cars, they should work at night. And they can actually use this principle of spatial summation to put it in the software of the cameras and make them more sensitive and benefit from the tricks of the Queen of the Night. So remember, life is easier with a little help from our friends, and so is vision at night.
Thank you very much, Anna. Any questions about the photo? Yes, sir.
How it is by the other animals like cats or the animals like mammals that see good and dark?
That's a very good question. So, actually many mammals, including ourselves, also have this principle of spatial summation in our eyes. We have a lot of processing that goes on in the moth brain already in our eyes. And we have special cells in our retina, that is the part of the eye that's kind of the detector, like the detector in a digital camera, that collect information from many of these photoreceptors. And especially in the mammals that are active at night, they collect from many, many, many photoreceptors, while in the animals that are active during the day, they collect from much fewer photoreceptors. So yes, mammals have exactly the same principle.
And who's the world record breaker at spatial summation or spatial summation? Who's the best at it?
Who's the best at it? That's a good question. I actually would guess that, well, that's a very good question, that mammals to some degree are probably the world record breaker. We sum over thousands of photoreceptors, but we do that in the periphery of our eyes. This is not where we see very sharp. So to some degree, this is not really what is very useful to see fine details. So if you compare it to what the main part of the eye sums up, it's probably, I think my moths are doing pretty well in there. So they're summing over like 60 to 70 of these detectors. Not quite as much as humans, but they actually do that like over their whole eye, whereas we do it only in the periphery.
But presumably we lose some sort of resolution.
Yes, exactly. As does the moth. It's a trade-off between being very sensitive to see at night and having very high acuity vision. And you can all try that when the light gets dark tonight. You see much less fine details when your eyes switch over to night vision, when you start integrating or summing signals from many detectors. You can try it. Just take something with many, many fine patterns on it, look at it during the day, and look at it during the night, and you will see that your resolution actually goes down.
So that's why my wife turns the lights off. Okay, any other questions? Yes, sir.
I would like to ask, do you know how night vision goggles work?
Oh, they're cheating. Yeah, so mostly they send out light, but infrared light, it is light with a very long wavelength that we normally don't see. So they send out light like a big torch basically, and then we can see everything with the infrared goggles that help us see this infrared light. So it's basically an equivalent of running around with a torch at night, but because we can't see infrared light, we think that, yeah, we can see things without any additional light. We don't. It's just enlightening everything with the light we can't see. Any questions? Yes, sir?
Yes. Sorry.
You're going to know that if our body recognizes that dark around us, we produce melatonin and then we fall asleep. But if you could see at night, then we produce the melatonin and we don't sleep.
You mean if we could see well at night, like Johanna said, we wouldn't go... Yeah. Well, I think that's a very... I mean, yes, moths apparently do this. So moths are very sleepy during the day, and you can poke them and do whatever you want, and they just hang on their cage and don't do anything. But I mean, I don't think that if we all run around with night vision goggles, we all of a sudden don't fall asleep anymore. It's something that evolves in the history of an animal is when they start seeing better at night, they start getting more active at night, but that involves much more than just the eyes. That involves a lot of the control that Johanna talked about in the brain and in the rest of the body. So yeah, I think if you just get night vision goggles, you won't get a night owl from that.
And so, why moths? If even mammals do this summation, why moths?
Well, moths or insects in general have a big advantage when you want to learn something about how neurons interact and how brains work, because they are very, very simple. They have many fewer neurons in their brain. For example, humans have about, I guess, or primates, about 50 different types of these ganglion cells in the retina that do all sorts of different tasks, and also the spatial summation. Moths have about 5 equivalent neurons. So it's much easier to understand the basics on a very simple animal like an insect, and then once you understood the basics, you can move to more complex animals, and already knowing many important things can see how it's done in a more complex way, basically.
So it's got a simpler brain.
Yeah.
But you obviously haven't met the President of the Czech Republic. Any other question? Can the principle of spatial summation, can it be used at other wavelengths of the electromagnetic spectrum? For X-rays or coming from radio waves?
I mean, it's a very general principle. It's basically just sampling from a bigger population when you have a very unreliable signal. It's the same as if you're trying to catch a little fish in a big pond. You won't take a little net and fish for it, you will take a big net. It's a very simple principle if you want. The interesting thing is to see how it's technically done or biologically done in an actual organism.
Okay, thank you very much.
What's wrong?
Feeling really nervous.
You're nervous?
All the people. I think I need a bit of liquid courage.
A bit of liquid courage?
Do you have anything?
Yeah, let's put it back.
Don't tell him.
Yeah, I found something. I've got something here. I think this should do the trick. It's a single malt and everything with it. What's going on? I can feel heavy. Listen, 1 minute. You've done the dark matter trick on me. Got you.
Thank you. Smooth. Well, as much fun as this is, watching you getting pulled down by the gravitational forces of dark matter, we'd better crack on. Please welcome to the stage our next presenter, Bogdan Chiorciu from Romania.
Hello everybody. Would you like to know exactly what dark matter is? Well, so would I. It even sounds mysterious, doesn't it? Dark matter, like it was taken from a story filled with knights, wizards, and dragons. But that's not what it is about. Unfortunately for all the geeks here, me included. Well, there are only 2 problems with the name dark matter. The word dark and the word matter. The word dark doesn't actually mean dark. It means we can see it, we don't know what it is, or where it comes from. The word matter is very misleading because we don't know what it is. How can we say it's matter? A better name for it would be unexplained gravity, because you see, that's actually what it is. In our universe, stuff likes to orbit other heavier stuff. That's just how it is. The moon orbits the Earth. The Earth orbits the Sun. The Sun orbits the center of our galaxy, and even galaxies orbit a common center of mass. But there's a speed limit to it. Well, imagine I was rotating a ball on a chain, like this. The faster this ball is moving, the stronger my grip needs to be to keep it rotating. Otherwise, if the ball is moving too fast, it will escape my strength and it will hit one of you in the head. So this is pretty intuitive. Well, scientists, when they look at the galaxy, for example, they see something very spooky. The stars that are closer to the edge of the galaxy are moving way too fast. They are moving so fast, actually, that they shouldn't be orbiting anymore, but they should be flying off, God knows where, into intergalactic space. But they aren't. Gravity keeps them in orbit. But whose gravity? That's the mystery. Because we look at the visible stuff in any galaxy, we calculate their mass, we add it all up, and we get 8 times less gravity than we should. 8 times less. Now my question is, where is the rest coming from? There must be something else hidden in there that has 8 times more mass than the entire visible galaxy. And that something is what we call the dark matter. These mysterious sources of huge amounts of gravity. No wizards, no dragons, but still absolutely fascinating. And I personally can't wait until we solve this mystery completely. Thank you.
Any questions about dark matter? Or anything space related? Black holes. Anyone seen Interstellar here?
Aliens, come on, everyone.
Yes?
Don't tell me how it ends, I haven't seen it yet, okay? Please.
This might be a very stupid question, but you're saying that it's something which is preventing these galaxies shooting off, but is it not possible that somehow the matter that you see is interacting with one another and amplifying the signal?
No, gravity is the culprit here. So we have to find sources of gravity, and sources of gravity have mass, and all the mass we can see is 8 times less than what the math shows. So the mass that accounts for the other 75%, 85% is not seen.
What if your math is wrong, I suppose?
Yeah, maybe the math is wrong, maybe Newton is wrong, maybe Einstein is wrong. We are working on multiple theories, even the one which says we are wrong about everything. Imagine we were wrong about gravity.
So what are you using? What kind of machines are you using to detect dark matter?
Well, we can't see it, okay? So light does not interact, light in any way does not interact with it. So we need other ways to see it. And we call the particles of dark matter, because we assume they exist. We call them WIMPs.
WIMPs?
WIMPs.
WIMPs.
Yeah, WIMPs. It's an acronym for a weakly interacting massive particle. So it's a particle which has mass, but it interacts very weakly. So we hope that some of those particles are all around us, even on Earth. And we use some germanium plates. Well, that's just an example. We use germanium plates and hope that some of those particles hit the germanium nuclei, and that would help us detect dark matter. But none.
No luck yet.
How can you discover something like the dark matter particle if we still don't have a quantum theory for gravity? Is it?
Maybe dark matter doesn't even exist. Maybe we're wrong. I don't know. Nobody knows. We're just working. We're just waiting.
Because to me, I mean, as far as I understand, as a humble chemist, trying to think about physics, as far as I understand it, gravity is the big sort of elephant in the room that we don't really understand fully. There's no way to unify it to electromagnetism, and so it's very difficult for us to perhaps understand what the question is.
That's very true. We only understand 4% of the universe.
And so, how do WIMPs avoid electromagnetic fields?
Assuming they exist. WIMPs. Actually, we don't know how they avoid it. So assuming they exist, they must avoid it somehow, so we have to understand about that too, once we discover them, if they exist.
Any questions? Yes?
Yeah.
When you said that you can be wrong in everything, is it possible that the early science, like the early studies of physics that used the ether or something like the ethereus as the main like part of the universe, could it be like more truthful than today's science? Because I see that from some point there are more like hypothetical objects that could be in space, but nobody knows if they are really in space.
So you're asking me if we could be wrong about everything we assume?
No, I'm just asking if
understand the question.
I think I understand, gentlemen. I think what he's saying is, as we understand our universe now, we propose things like fields, whether it's a Higgs field, so we can understand mass, or if it's an electromagnetic field, so we can understand light, and these fields perpetuate the entire universe. And particles either interact with these fields or they don't. And that's what we use now to be quantum mechanically define how things work. Whereas the gentleman here is saying that previously there'll be talk of the ether. So there would be outside our planet, if you were to leave its atmosphere, you go into this ether, which has all these properties. And he's asking, do you think should we look back at these previous theories? Is that right?
Yeah.
I think we should consider every theory, and we shouldn't say, no, that's ridiculous, that's not true, until we see evidence for it. So, exactly how you said it, we could be wrong, and so did Pori. That's the main motto of a scientist. I could be wrong. And especially for other scientists, you could be wrong. That sounds even better. So, if you have a theory, you have to have evidence for it. That's valid for every theory, ancient or especially new. So, if there is evidence, everybody will jump on it.
I think it's like written in some book from physics from the 20th century. It's called Electric Space. I don't know if you've heard of it.
I haven't.
It's like considering the existence of ether in the void in space. I recommend it to read.
Okay, thank you very much.
You'll find something that I could call evidence.
What do they suggest that ether is?
Well, I didn't read it. I didn't read it completely.
Yeah. No, because, well, I mean, current science suggests that the ether is fields, electromagnetic field, the Higgs field. Okay, so they're not matter themselves. They're fields from which particles can either interact or form from them.
Yeah, but in that book you can more under there's another point of view on these electromagnetic fields in the space. Like not that the most of the scientists think that that is good.
Anybody else read a book of similar? Any other? It's an interesting discussion. I'm enjoying it. Anybody else want to contribute about fields and stuff? Yes.
So one of the amazing things about astronomy is that because of the limits on the speed of light, you can look back in time at our universe develops. Does that tell us anything about what dark matter might be?
Unfortunately, no. That has nothing to do with dark matter. It really helps. We could study galaxies as they form. So we could look back in time and compare that with our galaxy and understand our galaxy better. But that doesn't say too much about dark matter, unfortunately.
But would the rapid expansion that occurred right at the beginning after the Big Bang, would that have been possible without the amount of missing matter, the dark stuff?
I don't know what math says about this. I don't know. Only a theoretical physicist could tell you that.
Any other questions?
I was just wondering about, you mentioned these
germanium.
Sorry, plant science. Germanium. But the question I have is, you know so little about these WIMPs. Why do you think that these detectors will work?
The structure of the germanium atom is ideal for this experiment. It's the only way we could detect them. So it's not actually, it's an important way in which could help us detect them. So it's not because we like it or because we dreamt about it. It's just we're hoping, and we're hoping using the most calculated method we have, and that is it.
Anyone else have any questions? Yes.
I would like to add something to the suggested book. I mean, I have no idea what the book is about, and I thank you for the suggestion. But what I would like to add is that
Perhaps an appropriate point to move on.
Yes, unless anyone has any other questions? No? Okay, thank you very much.
Hey everybody, my name's David. I'm the last speaker, I promise. But before you go, I'm here to tell you the story of the Tono Tono Man. So the Tono Tono Man is a middle-aged man, and he seems to be perfectly normal until you talk to him. And he responds with Tono 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 Tono. Right? It's weird. The thing is, A, he's real and he's on YouTube, and you should go look him up when you get home because it's wild. But B, Tono Tono Man is actually a really interesting case study in how language is represented in the brain. But studies like him are rare, so the question, and because it's actually very complicated to speak, from the tiny movements of your tongue to the really small ways that we express emotion, the question becomes, how can we study language separately from the actual act of speaking? Well, when we usually think of language, we think of spoken languages like English, French, or Chinese. But studies on sign language, scarce though they may be, actually give us really fascinating evidence on how language is represented in the brain because it's a non-spoken language. And in this way, we can avoid all the complex features of speech while still studying a language. Oppositely, Tono Tono Man has all these complex features. He has specific mouth movements and vocal emotion, but he still doesn't have access to his language. Tono Tono Man has damage to what's known as Broca's area of the brain, and this area of the brain is known to be involved in producing speech. When people have damage to this area of the brain, it seems like they know exactly what they want to say, but they just can't get it out. It's really bad if you're giving a talk, by the way. But the really interesting thing about Broca's area is that even though we know it's involved in producing speech, a recent study has found that it also activates when sign language speakers make signs. That is to say, as far as your brain is concerned, sign language is the same as any other language. It just requires a different set of muscles to express it. Because of this, therapists who specialize in autism have actually started to teach autistic children sign language as part of language therapy. And they find that children who learn English and sign language actually learn English faster than those who are only taught English. With all this in mind, I have to wonder, why do we call it sign language? It helps us communicate the same as any other language. And the brain treats it the same as any other language. Maybe it's time to shift our mindset on sign language by simply calling it
Any questions? How would you sign FameLab?
Well, I would spell it out. It'd be really fast and hard to read, but if you want to get special, you can use the F for famous. It's like drawing a big mustache, because famous people have mustaches. And then add lab at the end. Look at that guy.
That's not a mustache, it's a beaver.
Any questions? Yes?
How is with neologisms in sign language?
What?
How is with neologisms in sign language?
Neologisms.
New words.
New words. Oh, well, I'm going to put this down because that was huge. But new words are being invented every day with new technologies and stuff. It depends really on where you are. It used to be that sign language communities were very separated, and now with Skype and stuff, there's a lot more connectivity. But new words kind of evolve in the community in which they're born. And so that's why there's like 30 different signs for the word computer just in America. So it depends on who you're around and things that people just kind of start to pick up. But just like with any other language, new words just arise.
Okay, but if we ook inderdaad in one take how they
spread the word?
How do they form an equivalent sign for a new word in the spoken language?
Well,
That's right. Okay.
in order for that to happen, there needs to be some kind of link between the deaf community and the speaking community. And it's kind of weird. We don't immediately think of deaf people as having their own culture, their own community, but they do. And so that's why it's important for people when they're learning sign language, not just to learn the sign, this is how I say sign, this is how I say hot, this is how I say cold, but to also really engage in the deaf community and see how is it that deaf people are expressing this language. And if you want to become an interpreter for sign language, it's important for you to know the community that you're speaking to and know the way that they say certain words. So
Basically, just like with any other language, you
Just
have
with
to know the culture, not just the words.
Exactly.
How long did it take you to learn how to sign?
My signing is terrible. Like, really bad. Actually, don't show this to deaf people, because, like... But I started learning on and off when I was a kid. I thought it was cool. I found this book. I learned how to say, like, pizza and, like, soda and stuff. And then I met a friend. They taught me how to say all the bad words that I needed to know. That's what teenagers do. It takes, I think people go through a couple years of study before they can be an interpreter, and then even more years of actually, being close with deaf people, being close with people in the community before they become fluent in signs and they just, they just go. But I'm not fluent. I don't know, I didn't take a class. I probably should have.
Was there an example has there ever been an example for you where you found yourself before going to your spoken language, going to sign language to express yourself in a certain situation?
Oh, kind of. Yeah, it's like really, I don't know why, but now like the word for sign for angry is this. It's really visceral for me. I think this really feels angry, so now I'll be like, no, don't talk to me, I'm angry at you. So yeah, things like that. I think sign language is very much tied in with our kind of our instinctive response to things. So I think if you start learning sign language, you yourself too will be like, no, I don't care, I don't know, like really slangy things like that.
Yes.
So you say that the region that governs the language is the same in sign language and spoken language, but they obviously connect different parts of our bodies. So is there actually a difference in the brains of people that use sign language and people that just use spoken language because of that, and how that region is connected?
Yes, there is. As a matter of fact, so you can imagine that this area of language in the brain has a lot of connections to the area that controls the muscles in your mouth, because that's the direct connection between the muscles and your language. But in people who are native signers, the area of language the area that governs language has much more connectivity with the muscles that govern your arms, and also facial expressions. Facial expressions are really important in sign language. So even though the area that controls language is the same in the brain, the way it connects to different parts of your brain is a little bit different.
So facial expressions are important. So you mentioned also autistic people,
yeah,
and they have a problem often with facial expressions, or at least eye contact.
Yes.
So is there sort of a different accent or variation of it for autistic people?
I don't know. I've never seen an autistic person signing, but I imagine at the very least it'd be something that they would have to practice. A lot of times when you're learning sign, they say, and in order for this sign to be proper, you have to make a face like you're angry or your eyebrows up. With autistic people, I'm sure you have to really say, you need to scrunch a little bit your face, you need to really do this. The reason being because their emotions aren't immediately tied to their body language, and so you have to be really specific in teaching an autistic person how to sign with facial expressions.
Yes.
I have a deaf friend, and he said that he can't hear, but he can make up for it by seeing. He claims that he has better vision, especially very, very far vision. In your neurologic experiment, have you ever met this thing? Can you confirm it or not?
People, okay, so what I'm hearing the question is it true that when you lose one sense, you kind of increase your other sense?
Strengthen the others.
Yeah. I'm going to tell you that I don't know. But it's pretty clear that when you lose one sense, you at least have more, your brain has more of an ability to focus on your other senses. You're no longer distracted by the sights in front of you, or you're no longer distracted by the sounds. That input isn't coming in. So at the very least, whether or not it counts as being strengthened, you can pay more attention to these kinds of things. So yeah, I'd say in that sense it would be true, yeah.
Not better peripheral, but a better spatial summation. Isn't that right? Question there from the young lady.
My question is that is sign language international, or does every country have own sign language?
It's no, almost every country has its own sign language. A lot of people think that sign language, you'd think so, sign language is international. There's one across the board. No, American Sign Language, which is the one I know, is very different from British, is very different from French, is very different from Czech, apparently. The thing that they have in common is that they say, yay, they applaud like this, Americans and Czech signers, so that's pretty cool. But they're very different across different countries, the same way a spoken language is. People assume that they would be international, but in the end, they're the same.
Do you have dialects? Does sign language have dialects? So within, say American Sign Language, do you have dialects?
Yeah.
And how can you tell?
I think,
how does it manifest?
Yeah, it manifests itself in different signs. Like I said, it used to be, up until really recently, deaf communities were very separated because there wasn't the advent of the internet, telephones are useless, and so, each little group of people have their signs and they pass it down to signers that they meet. And so in that way, I think even more than spoken words, sign language communities have their own dialects, even stronger than you would imagine with dialects in America that being spoken.
3 questions over there.
I think somebody from over here. There's a hand raised. Yes.
In spoken language, we use intonation to change the meaning of what we want to say. For example, I can say this or this. And it changes the meaning of the word I'm expressing. And how do is there any way how to change meaning in sign language?
There is, wait, I think I understand. Like, when you're speaking, you can...
The way you sign.
Intonations, use intonation.
Yeah, intonation, that's the word. There is. With signers, you can be, you can be kind of mad, or you can be angry, or you can be pissed off. It has a lot to do with the size that you sign, the speed that you sign is really important. And again, the facial expressions not only come into play for expressing yourself, but actually kind of change the meaning of that one. They give the intonation that we usually have for spoken language, because they don't have intonation like that.
And so that means also sarcasm is also possible.
I think so. I don't know. I feel like, okay, here's the thing. Sarcasm in sign language, I still don't really pick up on. I'm pretty sure it's there, but like, I'm just trying to understand.
Yes?
How do you measure the responses in the brain? Okay, I've got 2 questions. This is the first one. So you just put someone in a scanner and tell them to sign and then see what happens?
Well, generally, as far as neuroscience experiments goes, there's a number of different ways to measure. You can put someone in an MRI and see how much activity is happening in the brain. You can use radioactivity to see how much blood is going to different parts of the brain, because they know that when one part of the brain is active, more blood goes to it. So there are different ways of checking to see what part of your brain is active. I'm pretty sure that for this experiment I told you, where sign language speakers activate this Broca's area, they were using MRI to scan activity of the entire brain.
And question number 2. There are certain apes that have been taught the American Sign Language, so you had gorillas and orangutans and some chimpanzees as well. Have there been any studies on them and their brains to see if they have some sort of a language center, and if when they communicate within each other, not using sign language, it's also the same part? And I take I don't know as a completely valid answer.
Well, that's good, because I don't know what's my answer. I don't know if there's been any studies that actually look at their brain and see if there's another language center in the brains of monkeys and apes that know sign language. But there are linguists that argue over this, and they say, yes, we see apes that can use sign language, but they're not using language. They just know the symbol for food. I want food. Knowing that as a sign is not the same as having a language. There's some linguists that argue, no, you need to have the system of grammar, the syntax. You need to have the ability to say more than food, drink, hungry, in order to actually have a full functioning language. Yeah? Yeah. That's the best answer I've got.
Can anybody else here sign?
Yeah, does anybody have any deaf friends? Anybody learn some sign language? Anybody learn some bad words and sign?
You can insult anyone, go ahead.
All right.
Any questions? Yes?
If for example, one of our Prague students was interested in getting to know the sign language, becoming an interpreter, so Ron, what would you suggest? What should they look for on the internet? What kind of books should they read? Who should they contact?
Apparently, Dasha, I'm gonna say she would know someone to contact.
Why don't you stand up and talk to me?
About 25 years now, we have at the Charles University a department which is actually studying the sign language. So whoever is interested, go to the Department of Sign Language at the Charles University. They can provide you with the books, they can provide you with the courses for interpreters, and they can also tell you about all the helpful things which the deaf people can use. Like they have the vocabulary, they have the interpreters on the phone when you need to deal with the offices or some kind of services. So it's the point where you should stand when you are interested.
Okay, contact Charles University if you need to know anything about sign language and the deaf community. Any questions? Yes?
I read a study recently that said that people in brain scanners who are showing videos of people dancing also have activity, that heightened activity in Brooks area. Could it be possible that dance could also be considered a form of primitive language?
Totally. So yeah, that's actually it's very, very possible that that would have connections to the way you express. In fact, the relation with signing and our language centers isn't just limited to sign language. They find the same kind of relationship in the way each and every one of us gestures when we speak. When we say things like, do things like, I don't know. All of these things are also linked with Broca's area. And so that's why when people have a stutter, they also kind of stutter their gestures. I don't know if anybody knows one of those. And so when you have damage to Broca's area, there's also kind of a loss of movements, of gestures that have meaning. So with that kind of study in mind, no, I have no doubt that dancing would have some link with our expression of language and the brain centers that are related to that.
Anyone else?
Time for one last question.
One last question, no one?
If there's not...
Yes, one more there. A very active corner.
I'm not sure, but I think that in Iceland they have it as an official language. So do you know how many people in Iceland are able to use sign language?
Shockingly, no.
I think it's just only one country where...
Yeah, it's actually... It's really weird and it's bad like how overlooked sign language is. There's like lots of polls that say these are the most spoken languages in America at least. But then when you take into account sign language, it is actually the fourth most spoken in America. So for some reason, our culture is that kind of forgets about sign language as an official language. And so I'm super excited to hear that Iceland at least is cool enough to acknowledge it.
Okay, on that note, thank you very much. Unfortunately, this brings us to the end of today's scientific extravaganza.
I think it's a big shame because I've really enjoyed it. I don't know about you, I've had a fantastic time. So if you want to know more about FameLab, then you can do so on the internet if you go to famelabcz.com. So have a look at that.
Or you can check out the Facebook page and our Twitter feed.
So, I mean, what's remaining is to thank once again the people who have made today's event possible. I think,
especially Dasha Sefton from the
young
British
lady in
Council.
the front.